Thank you again, and welcome everybody for joining us today at our virtual meetup titled "Your AI Transformation Part 2: Real-World Use Cases." During which we will learn how companies are transforming their business with the power of AI and where to start. My name is Saurabh Kumar, and I'm on the marketing team here at H2O AI. I'd love to start off by introducing our speakers for the day. First, we have Parul Pandey. Parul is a data science evangelist and a Kaggle Grandmaster at H2O AI. She combines data science, evangelism, and community in her work. She is also an active writer and has contributed to various national and international publications. Up next, we will have Shivam Bansal. Shivam is a data scientist at H2O AI and also a Kaggle Grandmaster. He's a 3 times winner of Kaggle's Data Science for Good competition and winner of multiple other offline AI and data science competitions. Shivam has extensive cross-industry and hands-on experience in building data science products. Without further delay, I'd now like to hand over to Parul.
Thank you, Saurabh, and thank you everyone for joining us today. And me and Shivam, we both are really excited to be able to share some of the compelling use cases that many of our customers are doing right now as they continue on their AI transformation journey. I hope I'm audible to everybody and my screen is also visible. So I'll begin by introducing H2O.ai and what we are and what we do. Those who had dialed in last time are already familiar, but for the folks who've just joined in, I think let me just start off by giving you a brief overview of our company. So H2O.ai was founded in 2012, and we closed a Series D funding in August last year, with Goldman Sachs was leading the round and Ping An Insurance and Finance out of China contributing as well. So H2O.ai is the creator and inventor of H2O open source platform. And today about 20,000 organizations, businesses, governments, universities, they use our product. So we also brought in H2O Driverless AI in late 2017. So it is one of our flagship products for automatic machine learning. Today, our team, which is global, comprises of over 200 people, and we are also expanding. We have some of the best AI experts, including the Kaggle Grandmasters here on our team. And we are a global company. We are headquartered in Mountain View, California, but we have offices in New York, London, Paris, Chennai, and Singapore. So this is essentially of who we are. Now, I'd just like to throw some light on what our mission and vision is. So our mission at H2O.ai is to democratize AI for everyone. And we believe that every company can be an AI company or an AI economy and not just the superpowers. So we are constantly empowering companies with our leading AI and machine learning platforms, our expertise, our experience, and training, so that they can embark on their own AI transformational journey. And we have some really good examples, which I'll share as this presentation proceeds. So H2O essentially is all about democratizing AI. And that's exactly where we got our start. So we started by open sourcing a compelling set of algorithms and a framework, which is known as H2O. And today, along with that, we also have a suite of other state-of-the-art products, including our automatic ML platform called Driverless AI and our business platform called Cue. So we are also involved with the community, and we are leading this AI open source movement. And we also stand for AI for Good, which essentially means using machine learning and AI to do some good for the society and the world as a whole. So this kind of sums up our vision and mission statements. Now, going from there, let me just sort of introduce you to some of the business questions that many companies and businesses they ask and are continuously asking. So they're asking everything from how do we do better forecasting? How can we do more efficient supply chain optimization? Where do I find my next best customer? How can I detect fraud? What's my risk? What's the likelihood of this customer actually buying from me? And so on and so forth. So these are some of the questions which are prevailing in the industries today. And those industries can go on from healthcare to marketing to real estate to telecom. And these are some continuous questions that companies have, and they're trying to look for answers. And machine learning and AI are helping them solve such problems. So a compelling example to that is this slide. So on the left hand of the slide, if you'll see, these are a lot of our open source statistics of the 20,000 plus organizations that are using our H2O open source platform. If you look closely, you will see half of them are in the Fortune 500, and like these are the who's in who's of banking, of insurance, of healthcare. Similarly, on the right-hand side are some of our customers who are using our enterprise product called Driverless AI. And again, I think these are some of the compelling logos in the domain and domains of financial services, insurance, manufacturing, healthcare. And these are not all, but some of the ones whom I could just accommodate on this slide. So this gives an idea about how the leading companies are using AI to actually solve some of the most important and vital problems of their businesses, and are also getting some great results. So talking about H2O and how we are helping our customers win with AI. So, today the AI transformation isn't limited to just one industry or one use case. It is actually affecting every industry on the planet. So listed here are some of the use cases that AI can enhance and solve and has actually solved. And if you'll see some of the major customers over here, they are in marketing and retail, in telecom, in healthcare systems, and some of the questions like in financial services, like know your customers, anti-money laundering, real-time targeting. Then similarly in healthcare, you can have some problems like drug discovery, medical test predictions. And in this current scenario of COVID, we are also working with the organization like Kaiser to predict when would the sepsis set in, or maybe number of hospital beds required in an hospital, and similar kind of ones. Again, for marketing, retail, we are doing some of the problems like identifying the next best offer, customer segmentation, customer churn. So these are some of those prevalent examples in which H2OI has been involved with its customers. And those customers are actually having great results, which is also evident in this next slide. So these are some of the statistics which have been given by our customers, and how having involved AI and machine learning to solve these problems have given them an edge, be it reduction in planning, be it increase in sales, or increase in customer churn predictions, debit reduction, and so on. So this is some of the ways in which H2O.ai has been involved with its customers, and we are helping them, and we have actually converted them to an AI transformed organizations. So going forward, let's talk about some of the customer stories and their AI journey, and which is going to give you a clear idea as to how these companies are using our expertise coupled with their resources to bring out a new story, a new transformation. Starting with one of our valued customer is PwC. So we've been working with PwC for a number of years now, and we are actually working with a part of their organization out of their innovation center in London. And they approached us and they said that they were facing 4 critical challenges. So they had talent challenges. They needed some innovative approach for upskilling their existing resources, and they had to even plug the attrition. There were some manual limitations because PwC auditors were doing the same thing repetitively, and they were all redundant tasks, and they were doing it all manually without any intervention of machine learning. So they also wanted to understand how they could digitally transform their whole business objective and scenario. And then they wanted to utilize the foundation that was built through digital transformation to identify some of the high value cases and innovative cases. And with all these problems, they sort of approached us to see how H2O could help with their experience and with their expertise. So what we did, we worked with them, and over the course of few years, we worked very closely with their team, and it was from 2015 to 17. And we sort of worked on some co-innovation, which gave rise to a product called GL.ai, called General Ledger. And in fact, this product also won the Audit Innovation Award in the year 2017. And this sort of saved a lot of time for the PwC team. So this was an intelligent bot which could pinpoint errors in their maybe audit reports. And this also helped to find some of the frauds immediately, which humans would otherwise miss out. And so this was a very fantastic product. And then going from there, we took a step further in the next few years, and then again with the collaboration of PwC and H2O, we brought in a product called Cash.ai, and this product also again won that award in 2019. So what this product and PwC now is doing is they are reimagining what audit could look like, and how we could find anomalies in the system and in behavior so that we could catch it in real time or near real time versus catching anomalies in the audit at the end of the quarter. So now AI can find, and machine learning can do all these things very quickly, and you can create machine learning models, they can also detect fraudulent behavior. So this sort of was a game-changing aspect for PwC. And Gary Rapsey, who is our contact there and who's a leader there at PwC, gave a very compelling statement. And he said that part of the reason for wanting to work with H2O, of course, apart from their expertise in the field, was their passion and purpose around advancing finance and democratizing AI for finance. So this is what feedback from one of our customers to us. And we intend to provide the same kind of service to other companies in financial sector, in healthcare sector. Let's go on to another story that we have on Wells Fargo. And again, Wells Fargo is one of our key customers, and they have an enterprise-wide AI initiative underway. So what they were looking for was many, different use cases like churn, customer retention, again, consumer spending insights, the data quality. And again, we are working with them very closely, not only on these cases, but also on machine learning interpretability. So that is one of our ability of our driverless AI product. Now, machine learning interpretability is very important, and it is a very important aspect of responsible AI. And now Wells Fargo is using that capability to turn their bank into a trust center. So it's using machine learning and the ability to explain the results by not only showing the answers to their customers, but also to the regulatory bodies, because I think that's a very important and a very big part around the whole trust factor around AI. And if you can see the use cases, that these are all the use cases where we've been working with them. Moving from Wells Fargo and banking, here is Nationwide Insurance. And now they've been doing data science for a decade now. And again, we've been working with them for the past 6 to 7 years. They initially started with our open source software, and slowly they started using our enterprise product also, Driverless AI. And they're serving multiple use cases across multiple businesses through their centralized data science team. So they have life insurance business unit, they have homeowners insurance business unit, they have an automotive health care, and they even have pet insurance. So in fact, they're one of the #1 healthcare pet insurance providers in the US. So they are seeing, how millions of and tens of millions of dollars of savings by using AI and machine learning. And not only savings, but it is also giving them better predictions. And it is helping them to decrease the time that was required for deployment of their models from like months to weeks and days. Now, if we turn from like insurance and banks and financial services to a large US telco with whom we are working, and they're doing some amazing work around many of the use cases. For instance, subscriber churn, identifying which subscriber is going to churn out, to recommender engines, to even, like the campaign optimizations, like what is the next best offer for you or for their consumers, to even tasks like where do we put our next 5G network tower. So all these use cases, they are using machine learning and capability and driverless AI for all of that. Now, a very interesting thing here is that they actually started with just one use case where they employed H2O AI services. But today, they actually graduated to solving all these above use cases. So again, for other companies also, they could also start with just one use case, and then they could see what probable benefits they are getting out of it. And then maybe they could start increasing the number of use cases they're using with machine learning and AI and compare sort of that. So this is a very interesting use case, and that's called Hortifruit. So Hortifruit is one of the largest producers and distributors of world's berry on the planet. And we are also working with them, or you could say they're working independently because they're just 2 data scientists on the team, but they are using driverless AI. And you'll see here that driverless AI coupled with just 2 data scientists helps them to actually get their work going. So Hortifruit, it requires a large worldwide network of farms and flexible and reliable supply chain that can deliver fresh berries throughout the year. So Hortifruit is a grower as well as a supplier. So it wanted to better understand, how to deliver the highest quality of fruit at the final destination. So you could say that, they wanted to know before shipping the product, or like the fruit in this case, what were the chances of their fruit getting spoiled, so that and they would take into consideration a set of variables like the variety of the berry, the weather conditions, the shipping container, and how like the method of shipping. And they wanted to determine the quality of that fruit before arrival. So they used driverless AI, sort of they stumbled upon it and they started using it, and they devised ways to actually predict product yield upon the delivery using data about the berry combined with all the other conditions. So now this actually helps them, because if they know that, keeping all these conditions in mind, the product will not be delivered on time, so there's no point in actually sending that product over there and then it just gets spoiled. So this is a very good example of they are like forecasting, and how a business which is not related to healthcare or finance or insurance is also using machine learning to optimize their whole business around it. Next, and the last one that I'm going to talk about is Franklin Templeton. And again, it is working on many use cases. For instance, the most important ones are loan default prediction, especially in this current scenario where COVID has struck and the economy is actually reeling under that effect. And customer sentiment again, investment prediction, and again, they've had millions of dollars of saving by actually applying AI to their business problems. So these were some of the use cases that actually stand out, and which could be a good example to you to see how you can use the AI and machine learning knowledge to solve similar questions or similar business use cases if you also have. So how we are able to deliver and how are we able to work with the companies? So we follow this 5-part iteration cycle. So there are 5 key steps which we follow along with our stakeholders. We assess their data, we'll assess your data, we'll do some workshops with the in-house experts that we have. Then we're going to do some model development using our product, which has state-of-the-art feature engineering capabilities, machine learning interpretability capabilities, and deployment capabilities also. And then you will measure your KPI and what is your return of investment on that. So this is 5 key steps. That's the engagement cycle that we at H2O, this is through the cycle we engage with our customers, help them finalize their questions, help them put that questions into a machine learning problem, understand the data that they have, finally putting into production, and then evaluating. So with this, I finished the first leg of this presentation. Now I would hand it over to my colleague Shivam, who would help you understand some of the other use cases that we've been working on. So over to you, Shivam.
Thank you, Parul. Just can you confirm, are you able to see my screen?
Yes.
Okay, great. Thank you so much, Parul, for sharing all the excellent use cases that we have been working on. And what I'm going to walk through is one of the use cases, or maybe 2. And I'll show the demo and the platform, how we actually take those use cases and solve them end to end. So one of the most important use case that have came due to this COVID situation is lending.ai. Essentially, many small businesses all across the globe are affected, and so are their loans. Now, as a bank, as a lending organization, it has become important to understand what are some of the key considerations that bank needs to take care before giving that SME as a loan or not. Now, this is very important and interesting problem, because now not just one data set will be important, but there will be additional external data sets which will have very importance. For example, things like COVID cases in a particular region, or maybe some of the Twitter or social media information. So what we do in the first step is collect data sets, different data sets, which can be company's own data, which can be provided by us because we also maintain a repo. And at the same time, customers and organizations can bring their own data sets. One interesting example that one of the bank is doing, that they are analyzing how much hiring and how much job loss have occurred across those different companies, and they are using that as a metric to understand whether they want to give loan or not, or what will be the loan performance. And once we have all of these data sets, the very first step that becomes important is the auto augmentation, where we want to automatically and intelligently join all of these data sets and make a flat data which can be used for analysis and modeling. Now we have our platform called Cue, and we have a dedicated application which can do auto augmentation, and I'll also demonstrate that. Once we have that data, now it can be used to do analysis and modeling. And that's where our second platform, which is called Driverless AI, that is used to learn from that data, to understand which customers are likely to default or not, to understand the credit score or maybe fraud, which might have been witnessed from that data that we have collected. And finally, once we have the results, we want to understand what impact the companies are likely to get. And as an organization, what are our business metrics and how they are likely to affect in different scenarios. That's where we want to perform what if analysis and scenario based modeling to understand those results and business metrics. And finally, once we have proven the solution, then comes the stage of deployment and monitoring, where we can use other platforms such as ModelOps to monitor if there is any decay in the model, if there is any drift across the data sets. And that's where like we combine our strategy from a business problem to data sets to augmentation to modeling and to generate the outcomes, and then repeating this process that it becomes important. So let me demonstrate this whole use case that we did for an Australian bank. So this is one of our platform called H2O Cue. This platform provides capabilities to business user, data scientist, analyst to create different dashboards, to create notebooks. We can connect this platform to more than 200 plus data connectors. And I have already added this loans data, which has information about different entities. So what we see here are these small and medium businesses, and they are based out of Australia, and some of the other information like their state, their latitude, longitude, details of the owner, some of the demographic information, some of the banking information if they have taken loan in the past, some of the industries, and so on. And of course, we have the target variable. We understand whether they defaulted or not in the past. Now, this may come from a business rule or a business metric, where we can define that if an organization was failed to deliver the loan in less than 30 days, then they are likely to be considered as a bad loan or a good loan. And now the problem with this data set, as I mentioned, that this is just one type of data. It is missing a lot of other information. For example, we want to understand in this state where they are operating, how much COVID cases have increased, or maybe what is the effect of lockdown, so that we can understand in real time what are these sensing effects or dynamic effects and how they can affect our target, which in this case is whether they will default or not. So that's where in this platform, it provides capability to build app store. Now, what we can do is we can create different types of app. Of course, one can be data science applications, which we do in plenty. And then there can be industry specific applications. For example, in financial services, we have this lending app, which is an end-to-end solution. Now, what will happen once we start this app, we can choose our data that we have uploaded, and we can perform the first step, which is we want to auto augment this data set with many other external data sets. And those external data sets may come from different sources. So what we will choose a strategy. Do we want to bring external data sets by connecting to a bucket, or maybe we want local data or H2O data? We can actually customize how the augmentation strategy will be performed. For example, we can fine tune the matching percentage. We can pick some correlated columns, or we can specify how much correlation can we tailor. And most importantly, we can decide what type of matching algorithms we want to perform. There can be different type of intelligent matching that can be done. So we can choose, do we want more intelligent fuzzy match, or do we want this system, this application to decide by its own and perform all the steps? And once we have decided these settings, we can name our data that we want to save it as augmented Australian loans. And we go to the next step, where basically we try to connect to different data buckets or data sources. In this case, I'm connecting to an AWS bucket, because that is the place where different ETL scripts, data pipeline scripts, keep on dumping different types of data sets. Now, To show you what type of data might be helpful in this example, there may be business entity registration details, which is available on mostly government websites. There may be social sentiments. For example, nowadays people talk heavily about how a particular brand is performing, or they may put some negative reviews. So we want to capture that, and we want to understand whether it will affect the information or the loan performance. There can be census information, which is very huge data available for all the global, all the countries, and can be very useful. And some of the recent data sets, important data sets like COVID cases, or maybe the mobility change, how the mobility patterns of different types have changed. For example, vehicle mobility, foot mobility, and so on. And there can be other stuff, for example, education details, industry growth. In terms of US, unemployment data is very important. Oil prices have been fluctuating. This might be important. Or maybe let's say inflation rate, because recently we saw a lot of inflation was affected and a lot of unemployment claims were observed. So now in this scenario, what we can do is we can bring in such data sets, and we can let the system, let this application to identify the columns which can be useful, which can be joined with our original data in an automatic manner. And we can then decide that, hey, we want to perform this match. In this case, it shows a matching percentage. It shows that there is 100% match, because probably zip codes, states, they are likely to be augmented. And we can just let this system to do the auto augmentation. And if you go to our tables again, we will see our new table will be generated, which looks something like this, augmented Australian loans. If we go to the rows, we see all the other columns which we had in the original data. But if we go to the right side, we will see some new columns have been added. For example, the business name, the Twitter sentiment, Google rating, or maybe the renew date, days in business. It might be important to understand mobility percentage, which is coming from COVID and lockdown, COVID cases per population, the population of the region, COVID cases in that region, demographics detail, like what type of ethnicities live in those regions where those SMEs, SMBs are performing. And now this data is much more useful, and it may have some signals because we have augmented it with the external information. And once we have this augmented data, now we can go back to our application and go to the next step, where we want to do some analysis, or rather do automatic machine learning modeling on this data. So we will select our augmented data and we will create a new predictive model. Now, modeling in general can take a huge amount of time. That's where our platform Driverless AI accelerate a lot of the things, where it essentially do automatic feature engineering, automatic model selection, automatic model training, and do the fine tuning, and generates this very strong modeling pipeline in the end, which can be then used to do the scoring. So what we just need to do, we just need to define what is the target, what do we want to predict. So in this case, we want to predict whether they will default or not. We will just name the experiment augmented model, and we will select some of the parameters. For example, how much accuracy we want in the end. Do we want highly accurate model, or do we want to give more time to the system, or maybe we want more interpretable model? So since we are working in this use case is most in the financial sector, interpretability is very important. So we can give interpretability as the higher number, and we can then just start the experiment. With these initial settings, with just these 3 or 4 settings, what essentially has happened in our other platform, which is Driverless AI, the data is already added. If we go to the experiments, there is an experiment which has started already. And what is happening in this experiment, that all of those rows, all of those columns, they are getting analyzed. A lot of number of steps are getting performed. For example, here we see a lot of data preparation steps are happening. There is a shift detection which happened. Then there is a slight feature engineering which is happening. And this process will keep on changing, will keep on improving as the time passes by. And straight away we see that the system has prepared the modeling strategy based on the settings that we provided. And we see that this is then doing some parameter and feature tuning, and it will be scaling across the different infrastructure or the CPUs. For example, in this case, I have this 8 CPU system. It is scaling across different CPUs. And of course, the settings that we provided were very initial, but for more advanced users, we can always go to the expert settings where we can fine tune or dig deeper into some of the steps that we want to choose. For example, what type of models we want to choose, what type of features we want to generate, what type of settings in terms of specific use cases we want to add, or so on. And now what we see here is straight away, some of the models have started training. What we see in this graph, in this dot, is a one machine learning experiment. In this case, it's a XGBoost GBM, which used a combination of different features, which are shown here. And in the next iteration, it learned from the previous model and saw what did not work well or what worked well. And it is doing a evolutionary process in which it is not just learning from what has happened in the past, but at the same time, it is trying different ideas, and with the goal that our end business metric in this case is AUC curve, and AUC curve should be as high as possible. So what we see here is there will be different iteration, different features will be generated, different models will be getting trained, and they will keep on improving. They will collaborate with each other, and in the end will give us very strong scoring pipeline. Let me show an experiment which is completed. So this ran for about 7 iterations. I gave different settings, less accuracy, less time, and more interpretability. But once we have completed the experiment, we see a summary here. And in the summary, we can see that out of just 25 columns, 69 new features were created. So this is additional capability of this automatic machine learning platform, that it will generate new features. We can download the auto report to understand the whole process that has gone from starting to the end, to understand what was the overview, what was the sampling strategy, what models were trained, what transformations were applied, and in the end it explains the whole process and documents everything. So in a sense that it increases the productivity of the data scientist or anyone who wants to create the models, because these are some of the mundane tasks that as a data scientist we have to do, but this platform automates everything. In this case, it shows the scoring pipeline, what essentially happened, that some of the features were passed to GBM models, and then this model performed the prediction whether they will default or not default. We can also understand interpretability. We can understand what features have contributed the most. We can understand how the model predictions are likely to change if there are some changes in the original data by different means. For example, here we have used Shapley. Shapley is a very popular concept which is used to understand relative feature importance and their contributions of different features in generating up predictions. So in a sense that the whole modeling process that may take some months have been reduced to few hours, as we saw that the experiment which we started from Q is already about 95% complete. It has already tried out about 10 iterations, and we have already got best about 0.9 AUC score, which is good enough to consider the model to be used in the business case. Now what happens when we have obtained this model? We go back to the lending app, and we go to the next step, which is essentially learning and understanding what will be the impact. So what we will do some scenario based modeling or scoring, in which we will select the model which has already been trained from Driverless AI. We will select another data, we will select our target, and we want to create different scenarios. Now the idea of scenario is there can be worst case scenario, there can be good case, there can be best case and moderate case. So we basically want to generate different scenarios, and we want to simulate something. For example, we want to simulate what will happen if the COVID cases per day likely increases by 10% or 20%. Will our default rate be affected if this happens? Or what will happen, let's say if as a company we increase or decrease the interest rate that is given to different loan applications. So maybe I just take two examples, and I pick some other columns that I want to understand, and amount column to understand how much amount as a company we might lose, and then we can generate these scenarios. So let's say in the first scenario, our default threshold cutoff we keep less, about 0.25. The interest rate, we can say that we can increase up to say 16% with the standard deviation of 3.5%. And we assume that in this scenario, COVID cases will not increase, they will likely decrease. And on an average, there may be around 400 cases per day with a standard deviation of say 50. But in the other scenario, we want some different parameters. First of all, we increased the default threshold to on a higher side, maybe let's say 0.6. Interest rate in the first scenario we kept to 16 mean, but in this case we keep it less. But we keep the COVID cases on a higher figure. Maybe instead of 400, they may increase to say 3,000 per day, which is higher as compared to the other. And now we can just do the scoring. Now what will happen is that the data will be simulated based on our input parameters, and it will be scored using Driverless AI. So both of these platforms are actually connected to each other, and the data that we prepared here is getting scored, which essentially means that data in scenario 1 is getting scored, data in scenario 2 is getting scored, and data in the baseline scenario is also getting scored to understand what are the impact, what are the final business metrics. So this will run for a few seconds, but rather I'll show a completed final output of what will happen once the scoring is complete. In the end, it basically generates a dashboard which shows all the business metrics and gives high-level insights with a deep dive to understand in this scenario where the threshold was around 0.2, the expected losses are this, about 28 bad loans are expected, about 40% of bad loans might be exist. This was the distribution of simulated variables in this scenario. This was the distribution of target variable in this scenario. And this is the breakdown or default rate. Most likely in South Australia, the default rate is likely to be higher in this scenario. And this is some other distribution that will be observed if this scenario occurs based on what model has learned. And of course, then we can compare the same results in the other scenario. In this case, we can see, are those graphs and charts different, or are they mostly the same, or we see that some of the categories are affected or not. But the story doesn't end here. We also want to make sure that all the results that we have explained via a dashboard to business users are fully aligned with responsible AI. We want to make sure that the results are explainable, interpretable, ethical, secure, human-centered, and they are also compliant, because we cannot just reject loans of individual based on what model has learned. There has to be concrete explanations. So in this dashboard, it also shows why a model is taking particular decision. In the first section, it shows that what are some of the high level features that impact the decision making. We can understand at a customer level. For example, this chart here shows different customers and their model prediction. The ones on the green side are likely to default, and the ones on this pink side are not likely to default. And when we hover over, then we can see the reason codes. So the reason codes are basically the contributors, and what is contributing to those individuals that will make them default. And finally, we can understand how the behavior will change of models if the data or a variable is changed. For example, if you see that if the outstanding balance is increased slightly, then slightly chances of getting defaulted will decrease. But if we increase it to very high number, then slightly they will increase. But of course, the highest will be achieved when the outstanding balance is low. That is shown here. And of course, we want to understand if there is any bias in the data, where we basically checks, let's say across different variable, their categories, is our model accurate or fair enough across different categories. For instance, here, if I just look at the accuracy, we see that our model is best accurate in New South Wales, but it is slightly less accurate in Victoria, and in Northern Territory. All the other ones are almost the same. And finally, we generate the model transparency, where we give a simple decision tree of this whole complex process, because this may have many complex models, but in the end, to the business users, we give a very simple high-level chart which explains what is the modeling process and with all the summary as such. So this was one of the use case that we have done. We are actively working with one of the Australian bank on this use case, and the idea is that with this platform, similar type of applications, the whole app store can be built, can be developed, and that's what we have been doing for other customers, in some in telecom, some in healthcare, insurance, manufacturing, and so on. So that's it for my presentation. I would like to pass to our organizer, Saurabh.
Thank you, Shivam. And thank you, Parul. We have a few questions in the chat window. Let's try to get them by the time we have at hand. Okay. The first one, can we consider AI moral?
The AI is just a suite of tools, and it basically depends upon the kind of data that we are putting into it. So if the data is immoral, if the data is biased, you'd also get the output will also be biased. So AI is not, you could say, a person who has any morality itself. It's the people who are working with it and what kind of things they're inputting in it. So essentially, it is garbage in and garbage out. So what you put in is that you'll get.
Yeah, and also that while consuming the outputs of AI, it should not always be like that AI is right or wrong. It is just another data point for the business and organizations to consider, and they then can use that information to further enhance the decision making, that this is what data is telling us, this is what our experience tells us. Now it is up to us, do we want to take that decision or not? And it can vary from use case to use case.
Wonderful. Thank you, Shivam. Next question. Have you worked with any energy and utility-based organizations? If yes, can you give us a use case and what has it done to change their game?
I'm not aware of it as of now, but if Shivam, you're aware of it, you could share that. But again, if you want to know more about the other use cases, I think the white papers and the blogs are on our site. So you could even go back and read there. Yes, Shivam, if you have any idea about it.
We have worked on a couple of energy use cases and a couple of organizations in the energy and oil and gas sector, essentially. Some of the use cases that are very prominent, and one of the most typical use cases for us are predictive maintenance or early warning systems, where we analyze a lot of data, a lot of time series data which may come from different sensors, different IoT equipments, and that will keep on continuously monitoring some of the metrics and will raise an alarm if some metric might show some anomalous behavior, and it might trigger to the user to do some maintenance checks on different machines, different equipments that might need attention as such. This was one of the use cases that we did for one of the largest oil rigs in Malaysia, and that is Petronas, UTP, University Technology Petronas, where they have deployed our driverless AI platform across more than 100 oil rigs, and our platform is being used to monitor some of these anomalies or some of these behaviors that might not seem real, that might be anomalous, and it can then be utilized to take some decisions. So this is one, and of course we have some more use cases, but I think we can share later. Shell.ai is also using us for some of the use cases like understanding data tracking for furnace production delta forecasting, which is a very particular oil site, and they want to forecast some of the raw materials that might be required in some of the coming months or coming time as such. And there is a fuel volume which is one of the raw material for these sites, and they want to continuously monitor the levels of fuel volume, and they want to predict whether they are, or what is the lifetime of those fuel if suddenly the consumption might increase drastically due to some events, and they want to again give an alarm to the users.
Great. That's a lot of valuable information right there. Thank you, Shivam. Next question. How can I identify which problems can be solved by data science, and how would I then develop or implement a data science solution?
Parul, would you like to go first?
Sorry, my audio is broken, I guess. So the whole process of converting a business problem into data science problem, like I think I showed you one of the sort of wheel in my presentation also. So it's a process. It's a process which occurs in phases. First, you have to identify a problem. You have to sit down. You have to see whether you have the right amount of resources. You have the talent. Uh, you have, and also you would also have to understand that if you convert, what is your pain point, what you're trying to address, and will that, in any case, show in your current solution that you're trying to give. So once you identify a business problem, then you have to convert it into a data problem. You have to understand that for any machine learning or AI algorithm to work on it, you require data. So you have to see what are the data points from where you need to collect that data. And once you convert that business problem into a data problem, then you have to identify the platform or the architecture that you have to use, the expertise where you need to hire new people, or you have existing people who have the domain experience, they need to upskill, and what sort of platform you need, for instance, like using our H2O platform. Then you also have to understand what are the implications. You have to understand the trust and the ethical component of your decision, and responsible AI ethics, and in a way you have to keep human in the loop. So it's a big long process that takes place right from inception of the problem to the evaluation metric. Like once you actually complete and you deploy a model, you have to understand what are your evaluation metrics, what you're trying to achieve, have you achieved them over the time. Like you have to see, you have to benchmark it with the market. Like for instance, after 1 month, how much reduction or how much increase in sales you're getting. So you thought, I'm going to deploy a solution because I want a 10% increase in my sales. So after 1 month, you have to check whether it's happening. If it doesn't, then you have to go back, you have to iterate, you have to see where your model is not working well. So these are my 2 cents on the problem. I think if Shivam could add something on it, he wants to.
No, Parul, I think you have already gave a very comprehensive answer. That's really good.
Thank you, guys. Next question we have, what kind of metrics about driverless AI do you monitor to make sure it is working as expected?
So there are two types of metrics that can be utilized for this case. One are the data or machine learning specific metrics, which varies from model problem to problem. For example, in classification, we might monitor, say, accuracy or the loss or the AUC, precision recall, these type of metrics. For regression, we can use things like errors, RMSE, root mean square, etc. So all these are typical data science statistical metrics which our platform is capable of. But in some of the cases, we might want to adjust and we might want to use business metrics. For example, one of the bank in Korea, they wanted to monitor just the top 10 decile population that is the most important to them. They don't care about rest 90%. So with one of the feature that our platform provides is bring your own recipes. So with that feature, we essentially added that business metric into our platform, and instead of using the machine learning metrics, we are using the business metric top 10 decile percentage to monitor that we are getting the right results. So that is of course the one way. And once we have the models, we can always go back and do some business intelligence related stuff and see if the results are as expected, as aligned with the human knowledge or the domain knowledge as such.
Thank you, Shivam. Very quickly, let's squeeze in 2 more questions. How long does it take to go from project design to project deployment and to production?
Parul, do you want to answer that?
No, I think you can take that question because you could answer it from your experience.
Sure. Yeah. So yeah, based on my experience, what we have seen globally, first of all, this whole scenario varies from the maturity of the problem statement. So in some of the cases, we might want to start from scratch, where the goal is to procure the data first, do the data preparation, and then comes all the modeling analysis phase. But in some of the cases, maturity is high. For example, in some of the banking customers here in Singapore, they have already collected the right data sets. They have already identified the concrete problem statements, and they just want to focus on the high quality models that can be produced and get the results. In those use cases, the time to market can be as small as 2 weeks to 3 weeks, which starts from getting the data as the input, performing the modeling, getting the results, fine-tuning it, and productionizing it. With our platforms, it can be accelerated to 2 to 3 weeks. But in other cases where we want to start from scratch, a lot of time goes into data procurement and then data cleansing, data pre-processing. Then in those cases, it can be minimum 3 months to as long as 6 months as such. And of course, in some of the cases where we want to keep on taking the input, keep on taking the feedback, for example, in use cases like e-commerce websites, where regularly new customers keep interacting with the website, and on a daily basis, new data is getting collected. So there is an iteration loop where every month or so, all the pipeline needs to be refreshed, and the whole pipeline may take more time, because with time, more and more data is getting collected, more and more features might be created as such.
Okay, very quickly, one last question. Are the datasets required for augmenting added beforehand and treated for augmentation, or are they selected by the platform dynamically from data sources based on appropriateness of the scenario?
So I think the answer to this question is actually a mix of 2 points. We can create different buckets, different repositories where we can just add our connectors, and those connectors will keep pushing the data sets that are available on the internet, on the third-party websites, or which are offline. So those data repos and those data buckets will be a global database for all the other data sets. And when the application such as lending.ai app is run, then it intelligently selects which column or which information might have an impact if included in the original data sets. That's where it uses AI, it uses automatic fuzzy matching, it uses even the feature importances to decide this information might be useful, so let's add this to the original data in an automatic manner.
Thank you, Shivam, and thank you, Parul. We are at the top of the hour, so we'll stop. But there's a few more questions that I'd like to get answered, and write as a follow-up to our attendees and the folks who missed attending. Again, thank you to everybody who joined us today. The presentation slides and the recording will be sent out very shortly. Have a great rest of your day and evening. Bye.
Thank you, everyone. Bye.
Thank you.
Bye.